This is the EdPuzzle quiz for the section on types of chemical reactions. First, let's talk about the structure of chemical reactions. We always start a chemical reaction on the left side with our reactants, and these are our starting ingredients or starting chemicals. We then draw an arrow pointing to the right, and that shows us what our starting materials become. And on the right side, we have our products, and these are what we end with. So really, we're taking our starting ingredients, our reactants, and we're turning them into, that's the arrow, turning them into a final chemical, our product. And this is the structure of pretty much every chemical reaction. We start on the left and we read towards the right. As an example, if we were baking, say, a cake, we would take these ingredients on the left, we'd add eggs, flour, and sugar, and the arrow suggests that we would create a cake. A cake is our final product in this case. So I want us to be able to see chemicals as pieces when we try to figure out what kind of reaction they are. In this case, I've color-coded every element a different color. And what this really represents is kind of how these elements shift around. Zinc plus hydrogen and chlorine becomes hydrogen and zinc plus chlorine. So we can see that some of these elements are grouped, and really we're just switching their positions. Notice, though, that in some cases we have polyatomic ions like this NO3. Notice that it stays together on the left and right sides on the reactant and product sides. If something stays together, we treat it as one piece when it comes to these types of reactions. So when we're determining what kind of reaction this is, we would see Na as a piece, NO3 as another piece, and Ag as our third piece. Now let's go through a quick recap of the types of chemical reactions. I'm going to present these as reactions that are somehow related, and we'll start with synthesis and decomposition reactions. A synthesis reaction is a reaction that occurs when multiple reactants become one product. For instance, in this synthesis reaction, we have two reactants, NaCl, becoming one product, NaCl. If we say have a decomposition reaction, though, such as what's on the screen, a decomposition reaction is the opposite. That is when one reactant becomes multiple products. So in this case, we have H2O2, one reactant becoming H2O, and O2, multiple products. Another kind of pair of reactions is single and double replacement. If we look at this single replacement reaction here, we can see that this reaction occurs when one partnered chemical switches with another element or ion. In this case, my Ag switches places with my Na. So Ag goes by itself, and Na gets paired with NO3 if we look on the right side. Our clue for this type of reaction is to look for a single element or ion on both sides. In this case, we see Ag as a single element on the left, and Na as a single element on the right. So if both sides have a single element, it's probably a single replacement. A double replacement occurs when we have two pairs of chemicals and where they switch positions with one another. For instance, Mg and Ca switch their partners in this reaction. So instead of MgO, we have MgCl. And instead of CaCl2, we have CaO on the right side. Our clue here is to look for two pairs of elements on both sides of that arrow. And our last type of reaction is combustion. Combustion is a little bit different. Combustion reactions occur whenever a chemical reacts with O2 or oxygen. Color coding isn't as helpful to identify combustion reactions. You can color code, it just doesn't help as much. But your clue is to always look for O2 on the reactant side. If you see O2 on the reactant side, it is definitely a combustion reaction. Alrighty, let's have you try out the quiz. First, take a look at this reaction on screen. Our first question is going to be, what are the reactants in this reaction? So which of these chemicals are our reactants? And no, there may be more than one correct answer, so select all correct answers. What are our reactants? Next, what type of reaction is displayed on screen? Of our 5 types of reactions, which one do we see here? So the answers to this are, first, our reactants are Fe and S8, because those are the chemicals we start with. And our type of reaction is synthesis, because we have two reactants becoming one product. All right, let's try another one. This new reaction on screen. First, what are the products in this reaction? Which of these four chemicals are our products? And again, there may be more than one correct answer, so select everything that's correct. Next, what type of reaction do we see on screen? So what of our 5 types is this reaction? Our answers here, our products are going to be CO2 and H2O. Those are our final chemicals. And what type of reaction this is this? Well, it's combustion, because we have O2 by itself on the reactant side. That makes it a combustion reaction. For our next question, we have a different equation on screen. Take a look. In this reaction, what are our reactants? Which of these chemicals are our reactants? Remember, there may be more than one correct answer. And next, what type of reaction do we see on screen here? So first, same idea as before. Our reactants are our starting materials, and they're on the left side over here. And this is a single replacement reaction because Cu replaces Fe in this partnership. So instead of Cu and Fe2O3, we have CuO and Fe. There's one new partnership and single elements on both sides. So this is a single replacement. Next, take a look at this reaction. First things first, what are the products in this reaction? There may be multiple answers, so give every correct answer. What are the products? And finally, what type of reaction do we see on screen? So our products here are going to be CaO and CO2 because we end with these chemicals. And this is a decomposition reaction because we start with one chemical and it breaks into multiple pieces. That is a decomposition reaction. All right, for our second to last question, don't worry about products and reactants. Just let me know, what type of reaction do we see on screen here? Of our 5 types of reactions, which one is on screen? So this is a combustion reaction because O2 is by itself in the reactant side. We're reacting C2H6O with O2. That makes this a combustion reaction. And for our last question, take a look at this chemical formula here. For this reaction, don't worry about products and reactants, but just let me know, what kind of reaction do we see on screen? So this is an example of a double replacement because Fe and Al both switch their partners. Instead of FeS, we have Al2S3. Instead of Al2O3, we have FeO. So because we have 2 new groups, we have a double replacement reaction. And that is the EdPuzzle quiz on types of chemical reactions.